Friends, hope all good. Thanks for all the viewers and subscribers for supporting VLSI Fab from long. Those who new, please like, share, and subscribe the channel. And you can please share your thoughts or suggestions in the chat box. So let's start the video without wasting time. So in this video, we will discuss about timing budget. So this topic is very important in terms of interviews, and also timing budget is something which is the method through which we can conclude the big chips timing. Let's discuss the uh, budget in detail in this slide. Okay, so suppose you have a design. So as per specification, data should reach from port x1 to port x2, suppose within 3 seconds. Okay, now in flat design you can meet this timing very easily because you are aware of the number of cells, types of cells, and the wire length between point x1 and to point x2. So it's very easy to estimate the delay between point x1 to point x2, that is shown in the left diagram. Okay, so left one is the flat design diagram, and the right one is the hierarchical design diagram. Suppose this is a right side is a hierarchical design, and there are suppose three blocks in between point x1 to point x2, that is b1, b2, and suppose b3. Three blocks are there. Okay, so so all the blocks will be having their own different block owners, correct? So you want to make sure that everyone gets proper information, correct? Every block owner gets the proper information before they start their own work. Okay, before designing their own work. So like how much maximum delay for block b1, b2, and b3, so that should be known to the uh, designers, right? So dividing this, suppose point x1 to x2, in earlier it was like 3 second in flat, right? So dividing this 3 second into the these three blocks is called the budgeting. Okay, so as a definition, if I say this distribute the top level timing uh, constraint into a effectively into a block level constraint is called a timing budget. Okay, assign timing budget manually or automatically using your STA tool. Okay, so manual timing budget involves like setting the target delay or slack for each stage or block based on your design intent and experience. And automatic timing budget involves letting the tool distribute the slack evenly or proportionally among the stages or block based on the delay or logic that it have. Okay, uh, in this slide we will discuss like there are two types of budget. One is under budget, other one is over budget. Okay, so in the diagram you can see, suppose randomly you have assigned 1 second delay to each block. Okay, it is a hierarchical design, right? So in slide 2 we discuss like suppose from point x1 to point x2 we have 3 second length defined. Okay, in the top level constraint, like it is only allowed 3 second from port x1 to port x2, but suppose we are randomly given 1 second delay to each block, but you can see the cell delay of block b1 itself exceeding the 1 second, correct? So if you add the net delay after route, so it will be much more than 1 second, correct? So such type of timing budget is known as under budget timing, because see, it will violate the timing because all the three blocks will be like more than 3 seconds plus your net delay will be added up, and so it will be an under budget design. Similarly, if the suppose if the delay of the block b2 is very less, suppose, okay, let's assume it is a 0.2 second. Now we are defining it's 1 second. Suppose it is a 0.2 second, then estimate the 0.8 second for net delay. Okay, so that will be might be too much, correct? So we are estimating the cell delay less 0.2 second and estimating the net delay is very high 0.8 second, so that will be a kind of over budget thing. Okay, so this type of budget is known as over budget. So now let's assume that you have estimated the delay correctly for each block. Okay, like we discussed under budget and over budget, right, in the last slide. So suppose that time we have not estimated the budget correctly, correct? So suppose we have, now this time we have assumed the budget correctly, and suppose data coming from B1 block to B2 should know like that when it is going to receive the data. Okay, like after how much time with reference to the system clock it will receive the data. Since both the blocks are handling by different persons and they are closing the blocks independently, so we have to define few constraints at the input and output of each block in terms of timing and all. So this constraint can be with respect to a clock or data or both. So for this we can use set input delay and set output delay. Let's discuss the set input delay and set output delay in the upcoming slides. So now let's discuss the set input delay in some detailed manner. Okay, so the synthesis tool assumes the data is launched by a positive edge trigger flop from the external logic. Okay, so in our diagram the external logic is the IP2 and IP1 is our design. Okay, so data is coming from IP2 to IP1 through input port. Okay, so like okay, before explaining it, I just want to mention one thing. Like, if the data is launched by a negative edge triggered flop, then we must modify the constraint so that synthesis tool becomes aware of it. Basically, we have to include a clock underscore fall option with the constraint. Okay, so now let's again go to the example. Consider suppose this clock to Q delay of the FF3 is 0.2 ns, and suppose max delay associated with the combo logic 4 is 0.8 ns. Okay, so total it will be 0.8 plus 0.2, it will be 1 ns delay it will take from IP2 to input port, correct? So so if I need to write a command, so what I will write is set input delay underscore max 1. Why it is 1? Because total delay it is taking is 0.8 plus 0.2, that is 1 ns, that is the delay of combo logic plus ff3, and hyphen clock clk, that is the system clock, that is which is triggering the flop, and hyphen clock underscore fall because it is a negative edge triggered flop, and get ports underscore get underscore ports input 1, that is the port name that we have mentioned. So similarly here we can discuss set output delay. So like the synthesis tool assumes that the data is captured by a positive edge triggered flop. Okay, like the same way that we discussed for set input delay. So in the same way, like the synthesis tool assumes the data is captured by the positive edge trigger flop in the external logic, and the maximum output delay for setup analysis is suppose 2 ns. Okay, so if the data is captured by a negative edge triggered flop, we must modify the constraints and we have to use the clock underscore fall option with the constraints. Okay, so consider this example. Suppose setup time of ff3, that is the external design. Okay, setup time of ff3 is suppose 0.4 ns, and the maximum delay of this combo logic 4 is suppose 1.6 ns. Okay, so combo logic 4 is also external to our design. Okay, so like as shown in the figure, so ff3 is a negative edge triggered, correct? That is already I have shown you, that is ff3 is in the it is a negative edge trigger flow. Therefore to constrain the output port we have to use the given command, like set output delay hyphen max 2. Why it is max 2? Because it is the same it is the delay addition of 0.4 ns plus 1.6 ns, delay of your ff3 plus combo logic 4. Okay, so hyphen max 2 and hyphen clock clk, that is the system clock. Then same way hyphen clock underscore fall, that is the negative h, and the get ports, and this is the output port. Because why we are giving output port here, it is because we are using set output delay, and it is going from register to output port, correct, res to out path. So that's why it is we are giving output port. And hi friends, let's conclude this video. Thanks for watching, and please like, share and subscribe the video, and also please share your suggestion in the comment box. We will come with your suggestion implemented. Okay, thank you guys.